Let's prove this particular statement. Now we are supposed to prove this. So first let's read the statement. What does the statement say? The statement says that prove that the bisector of an angle of a triangle divides a side opposite to the angle in the ratio of the remaining sides. Now we read this statement. Does this remind you of something? Right? Angle bisector divides a side opposite to the angle in the ratio of the remaining sides. What is that? Yes, you are very correct. This is nothing but it is property of an angle bisector of a triangle. We are supposed to prove this statement. That means we are supposed to prove the property of angle bisector of a triangle. So we are supposed to prove this. So that's the statement which is given. So in the examination we would be given statement like this. Right? Now we know when we are supposed to prove a statement like this, first of all we need to understand what are we supposed to draw. Now from this we know what are we supposed to draw. We need to have a triangle. So let's have a triangle here, my dear kids. We have a triangle here ABC. And what do we require? Bisector of an angle. Bisector of an angle. Okay, in a triangle there are three angles. We require the bisector of any one angle. So let's say I'm going to consider angle C and I'm going to take its bisector. So we have the bisector of this angle C. So CE, is this the bisector of angle ACB right now? By the figure? No. Why? Because it will become the bisector only when angle ACE and angle BCE are marked equal. That means we need to put identical marks, my dear kids. This is very, very, very important. Okay. So this is what we were supposed to draw. So we have understood what we are supposed to, and whatever we have drawn is nothing but a given. So let's write the given. What do we write? In triangle ABC, the CE bisects angle ACB. You'll say, wow, this is interesting. So we understood from the statement what are we supposed to draw and what is a given. Now let's understand what are we supposed to prove. It says that if you are given the bisector of an angle in a triangle, then what happens? Then this bisector divides the side opposite to the angle. Side opposite to the angle. We are referring to this angle C because the bisector is of that angle C, right? So the side opposite to this angle C, which one is that? AB. This bisector divides the side opposite to the angle in the ratio of the remaining sides. Remaining sides. Which are the remaining sides? Yes, we are talking about AC and CB. And we know what does this property say. This property says that we have to get the ratio of AE and EB equal to AC upon CB. And these are the two ratios which we need to prove equal. You will say that is so very easy. So that means, my dear kids, we understood what are we supposed to draw, what is the given and what is the to prove. Now the question is, how do we prove this? And this is going to be very interesting. So when we have this in the examination, it's very easy. We draw the figure correctly, we get half mark for that. We write the given and the to prove correctly, we get another half mark. Now, only on the basis of this given can we prove this. No, there has to be something. And let me tell you a very important fact about this property. This property of angle bisector of a triangle is nothing but this is a property which we get by applying basic proportionality theorem. It's a property which we get by application of BPT, that is basic proportionality theorem. That means obviously we'll have to take the help of basic proportionality theorem. Now, I'll just recap what we know about basic proportionality theorem. Here, in this triangle, if you observe, in this triangle YXZ, we know this TM is parallel to XZ. Therefore, we get this ratio YM upon MX is equal to YT upon TZ. Okay, that is what we know about basic proportionality theorem. That means in basic proportionality, there's a triangle, there's a line parallel to a side, which divides, that line intersects, that divides the two sides in two parts. Two parts here, so that we get ratios. Okay. So that means in order to apply, if you want to apply basic proportionality theorem, we require such a line, which is actually dividing a side into two parts. Okay, observe here, in this figure right now, do we have any line which is actually dividing any side, which is intersecting any side and dividing that into two parts so that we get the ratio of those two parts? Do we have such a line? Observe. You will say, yes, we have that line. Which one is that? It is CE. Yes, so we have that line CE which is actually dividing this AB into two parts, AE and EB. And we get that ratio AE upon EB. And that is there here in the two group. You will say, yes, we have that line. Okay. What is that condition about that line? We know that if we want to apply basic proportionality theorem, we need to have that line parallel to a side, right? It has to be parallel to a side. That means we require a line which will be parallel to this line C. Okay, right now do we have any line which is parallel to C? No. So that means one thing is very clear, we require a construction here. So we have to have a line which is parallel to C, not anywhere outside, right? It has to be there here. Right, so what are the two possibilities you will have? There are two possibilities, right? We can have that line parallel to C passing through B, or it can be passing through A. Yes, it can be passing through A, or it can be passing through B. So these are the two possibilities. You can consider any one, my dear kids. And so we are considering this, we are having a line here which is passing through B and it is parallel to CE. So understand why are we drawing this. It's not to be memorized. Understand, there's a logic behind it. So you understood this? Okay. So you'll say now we can apply basic proportionality theorem. No, wait. This line has to be parallel to this line and this has to be the side of a triangle. So you'll say, how do we form that? Can we make that? You'll say, yes, it's so easy. Just extend this AC now. So now we have a triangle, isn't it? We have a triangle ABD where we have a line parallel to a side. So understand here, since this is an application of basic proportionality theorem, we need to apply basic proportionality theorem. So we did all this construction so that we can have that line parallel to a side. So understand there's a logic behind this construction. So whatever we have done in construction, which we have mentioned here with dotted lines, we need to write there in construction. It's very simple. What have we done? Through B, we have drawn a line which is parallel to CE and is intersecting AC at point D, my dear kids. And that is what we have done, such that A dash, C dash, D. Understand, this is important. So the entire crux of this property, of proving this, is nothing but understanding the logic for the construction, which we have done. So once we have understood this, now believe me, it's very easy, very easy. Okay. One more thing which I wanted you to know, very important. When you're drawing this triangle ACB, which we had drawn at the start, see there's a particular way we have drawn it. If you look here, this AC which I have taken, this angle at A, it's more acute. When I say more acute, that means it is going more towards AB, right? So it is tentatively an angle which we create at A, which is approximately between 30 to 45. So don't take it more like this, because when you take it more like this, it is difficult for you to extend and finish the triangle, to get that triangle. That is the reason. So take it more acute towards this base. Understand this. Remember this when you're constructing the triangle. Okay? So you understood this. So now why did we do all this? We did all this construction so that we can apply basic proportionality theorem. In which triangle? Yes, obviously it is going to be triangle ABD. So let's consider that. So we write in triangle ABD. You know the steps, right? What is that? We have a line parallel to a side. So let's write it. In this triangle, we have a line parallel to a side. So we write in triangle ABD, we have CE parallel to BD. What is that? Where did we get this? Because of construction. So do write the reason there. And because of that, we get the ratios equal. Which one? AE upon EB is equal to AC upon CD. Let's write that. AE upon EB is equal to AC upon CD. Beautiful, isn't it? And what is the reason for that? Basic proportionality theorem. You'll say, wow, let's mark this as statement number 1. We got it. Wait, we wanted two ratios to be equal. We got it. You'll say, wow, let's check this. You'll say, look at the left hand side. AE upon EB. We have got AE upon EB. Wow, beautiful. One ratio we already got. Look at the second ratio. In the numerator, we wanted CA. We have CA. Wow, excited? Look at the denominator. We want CB, but what do we have? CD. Oh, only for 1. We missed out. That means you are saying we don't want this CD. Instead of CD, we want CB. So what will you do? Simple. Erase CD and write CB? No, we can't do that. We're not supposed to do that, right? So you know, when can we write? Instead of CD, when can we write CB? We can write CB if they become equal. That means the hint is somehow we need to get CD and CB to be equal. Now when you look at CD and CB, you'll say it belongs to a triangle. Now let's think. In a triangle, when will we get two sides to be equal? Think, when will we get two sides to be equal? We'll get two sides to be equal if the angles opposite to them are equal. That means if the angle opposite to CB and the opposite angle of CD If they are equal, that means what we are saying is that we need to get this angle CDB and angle CBD to be equal, and that's the hint, my dear kids. We just need to get that. If we are getting this, we are getting the proof. Easy? So that's the way we think. That's the thought process which is important. Why did we do the construction? That is important. And then the flow of that proof. That is so very important. You'll say that's easy. Let's think. Now whenever we want two angles to be equal, you know how do we think? It's very simple. Yes, one angle at a time. Let's think about the first angle. Let's focus only on the first angle, that is angle CDB. I want you to focus that in the figure. Look at that angle CDB. Now when you look at this angle, you will say this angle, any angle, is always made up of two rays. One is DC here, the other one is DB. Out of these two rays, do we know some information? Do we have some information about any one ray out of this? You'll say yes, we know something about this DB. What do we know? We know this DB is actually parallel to CE. Wow! So in that case, the other ray of this angle CDB, the other ray, which one? DC, will act as the transversal for these two parallel lines. Understand? That's the way you think. So I just gave you a thought process of how you think. So when we saw this angle here, we saw one side is parallel to a line here, the other one will act as a transversal. So the moment this is acting as a transversal, we have two parallel lines intersected by a transversal. So focus on this angle CDB. This will be equal to some angle. We'll say yes, we have an alphabet F here. Yes, that means you're saying that we get two angles to be equal. Which pair of angle is that? It's a pair of corresponding angles, and we know when lines are parallel, corresponding angles are equal. That means we can write this angle CDB and this angle ACE to be equal. We know the reason, corresponding angle theorem. But now let's write the step. What do we write? First we write the lines which are parallel. So we write here CE is parallel to BD. What's the transversal? Mention the transversal. Yes, that's a transversal we wrote. And for this transversal, we get this pair of corresponding angle to be equal. Let's write that. Angle AC and angle CDB, they are congruent. Okay. And what is the reason for that? The reason for that is corresponding angle theorem. And this happens to be our next statement, next result. Okay. So we got something about this angle CDB, isn't it? Yes, we got. You'll say same way. Let's think about the next one. That is angle CBD. Okay. Let's focus on angle CBD. Okay. Think the same way as I've taught you. This angle is made up of two rays. One is BC, the other one is BD. Out of these two, do we know some information about anyone? You'll say yes, we know it already. That is BD and CE, they are parallel. Okay, so obviously the other ray of that angle will act as a transversal. So now, my dear kids, observe this. These two lines are parallel, this is a transversal. So what do we get about this? You'll say there's an alphabet. What is that? Z formed. That means you're saying, yes sir, this angle here, CBD, is actually congruent to angle ECB. Why? Why? Because this is nothing but it's a pair of alternate angles, and we know when lines are parallel, alternate angles are equal, right? Only thing, lines parallel, it's the same. Only the transversal would change. So we'll write there on transversal CB, what we get is angle ECB is congruent to angle CBD. What is the reason for this? It is alternate angles theorem, and this is our result number 3. You know what? We had to think about angle CBD. We thought it. We got it in result number 3. But my dear kids, we had discussed at the start that somehow we want these two angles to be congruent. We want these two angles to be equal. Now in result number 2 and 3, we can get this two equal provided we get angle ACE and angle ECB to be congruent. Now think, look at the figure. Angle ACE, this one, and angle ECB is this angle. We want these two angles to be congruent. Can we prove it? We need not prove it. It is already given. Why? Because we know CE is the bisector of angle ACB, isn't it? That means, my dear kids, we can write here that angle AC is actually congruent to angle ACB. From where did we get that? It is from the given, because we know ray CE bisects angle ACB. And this is our result number 4. We got what I had mentioned in the hint. This is already done. We got it. Beautiful. Let's focus there now. So from 2, 3 and 4, now you know this, right, left hand side, they are equal. So we can write the right hand side to be equal. That means we can write angle CDB congruent to angle CBD. From where did we get that? We got it from 2, 3 and 4, isn't it? But look at these two angles. These two angles, they are equal. In which triangle? In triangle CBD. So we should write that in triangle CBD, we have these two angles to be equal. And we know in a triangle, if two angles are equal, what happens? We know the sides opposite to them are equal. That means we are saying that we get the CD and CB to be equal. What is the reason for that? It is nothing but it is converse of isosceles triangle theorem, and this is what we wanted, that CB is equal to CD, so that we can replace the CD by CB. So we'll mark this as result number 5, and this result we'll substitute in this result number 1. So let's write that result number 1 again, right? And so what do we get? AE upon EB is equal to CA upon, instead of CD, we are going to write CB. From where did we get that? We got it from 1 and 5. And what have we got? We got the proof that AE upon EB is equal to CA upon CB, and that is what we were supposed to prove, my dear kids. Now, wasn't that easy? It's such an amazing property which we proved, and it is beautiful because it's easy. Only thing is, remember, we had to understand why did we do that construction. So once we understood why the construction was done, it was very easy to start the proof, and then the flow was very, very simple for us to end the result, get the result. Almost easy, beautiful, isn't it? Very, very important for your examinations.
And yes, please do not forget to like, share, subscribe, and press the bell icon.